Hello, everyone. So, to, am I online? I'm not sure I'm online yet. Okay. Well, my eyes don't look great without glasses. So, hello, everyone. Today we're going to work on. We're gonna build a little visualization that's going to show the. Sorry, I'm doing too many things at once, and then I can't talk. I'm out of practice. Ah, fuck's sake. I don't know why this always gives me the wrong link first. Let's fix that. So basically, what we're going to do today, we're going to visualize the difference between a completely random walk and a biased random walk. And the reason we're doing that is because Mr. Hamming in his book said that your career needs a vision. And the example he used to make his point is the concept of a random walk from mathematics. I'll read you the exact quote. So I got it from this book, and in this book somewhere, okay, well, I can't find it anymore, but I tweeted it. He basically says that a drunken sailor walks in a random direction, makes a new decision every time he makes the next step, and it doesn't matter how many steps you make, you're always going to travel a distance proportional to the square root of the number of steps that you've made. But if there's a pretty girl somewhere, or in our case, a vision for your career, then all of your random steps are going to be biased towards that direction, and you will travel a distance proportional to the number of steps that you make rather than proportional to the square root of n. So what we're going to try to do today is visualize that difference so that we can have little widgets that I'm going to embed in an article that I'm writing so that you can viscerally feel the difference between having a vision in your career and having zero vision and just responding randomly to events as they happen to you. That's the idea. It's going to be short and sweet, I hope, because I have a USCIS appointment that I have to go to. So let's begin. All right, so I'm gonna make my camera smaller. No, I won't. Why is it not letting me make my camera smaller? That's weird. Okay, camera is smaller. Please let me know if, yeah, this is definitely too small. So I'm going to start with this. I used this random walk example for a different article already, so I'm gonna fork this and we're gonna instrument it a little bit so that it explains better what we're doing here. And then we're gonna add the ability to add a focus point, which is going to be like having a vision for your career. So this is forked. I can, let's see. So you see the person down here is walking randomly. We're gonna say random walk, and let's so that's the random walk. This renders the circle. Okay, we don't need typing anymore. So we're gonna take that away. Actually, we can still use the breakpoint. We have the set interval, and we should probably add some way to actually start. Should we add a way to start the actual thing? Maybe. Okay, so we have add step, set random walk. That's what does the walking. Now here's what we're gonna have to count the number of steps that we have and show that in the visualization. So let's see. Okay, so we're gonna add a paragraph that says steps walked, and that's going to be random walk.length, steps taken. Your career is a random walk. It needs vision. Perfect. So steps taken, random walk, distance traveled. So to calculate the distance you have traveled, we need to calculate the what's it called? The Euclidean. Is it Euclidean? We're going to do some trigonometry and calculate the distance between where you were and where you are now. So between where you started and where you currently are. So we're gonna say, we're gonna get the distance between the random walk 0 dot start and last step dot end. So those are going to be the first step and the last step. That's the distance. Where do we get last step? Am I doing that up here? Yes, I am. Okay. So we're going to make a distance function distance, start and end, calculates Euclidean distance between 2 points. I think it's Euclid. Oh my God, this is gonna Euclidean distance. Let's see. Yes, that's what it's called. And that's the formula that we're going to use. Also, if you're in the chat room, say hi. So function distance is, how do you calculate the distance? You take both vectors, you sum, square. Okay. So this is going to be math.squirt of start. Are they, I think they are 2-element arrays. Yes. Start 0 plus, come on, where's the plus? Plus end 0 squared, and then start 1 plus end 1 squared. Like that. So that should be the distance, and let's round that. Math.round. Okay, so the more you're taking a lot of steps, but your distance traveled is not very large. Cool. So we've got the first part of this. Now we're going to add the ability to add a bias. Click to add a focus point. Click to add a vision. Add a vision. So when you click on something, that's going to add bias towards that direction for the random function that's, yes. Okay. And so click to add a vision, a focus point. Is it a vision point, a focus point? Yeah, click to add a vision. Your random steps bias towards it. Okay. And we're going to add a button to reset. So there's going to be button restart walk, because that's going to make it easier to deal with. On click equals restart walk. So then we need to make a function called restart walk that's basically going to take our random walk array and destroy it. So default walk const default walk, or starting point default walk. What should we call this? Doesn't matter. Starting point used to reset as well. Okay, so here we're gonna have function restart walk, which is just going to say set random walk as the default walk. Okay, So we have this, and when we restart it, we go back to 0. Should we make this smaller? Or rather, should we make it run slower? Let's add a set interval for 10 milliseconds. That might be a little bit slower. 100 milliseconds maybe? Nah. Let's just have no, doesn't need to be slow. So we can walk fast. Okay. Well, the problem is that these numbers go pretty quickly, so they're kind of hard to read, aren't they? Yeah, okay. So now how do we, now we need to handle a click on the SVG so that, let's see, I can make myself bigger for that. So now we're going to add a click handler for the SVG so that you can add a focus point to where you're going. And that focus point is going to be rendered as a circle. Maybe we're going to add some text around it so that we have, so that it says that that's the vision. And then we're going to, yeah, that should work. Okay. Biased random walk with vision. Okay. So now the random walk, how does that work? Okay, first the click. So we say on click equals what should it be called? Add vision. And we're going to have a function called function add vision, and this function is going to, first it's going to get the cursor position. So let's console log. But if we do it with, I'm gonna add D3 just for this, because it's going to make my life a little easier. So if we add, although it would be nice if it doesn't need D3, because then I can use it on my blog directly. Okay, we're gonna try to do it without D3. D3 has helpers that give you exact position of where you clicked in an SVG, converted for transformations and stuff like that. And I'm gonna see how that works. So I'm gonna try to do it without D3. Let's see. Each child should have a unique key prop. This is true. So let's add a key prop that's just an index. Index key equals index. All right. So let's see. Clear, click, no. Aha, synthetic base event on click, type, target, bubbles, view, screen X, screen Y, client X, page X. Oh yeah, that's why. That's why this sucks. Blah. Right, I think we can do page X and page Y. Let's try it. So const page X, page Y come out of event, and we're going to, or let's see here, we're gonna add a const vision and set vision equals use state, which is going to be an empty which is going to be null at first, holds the position of your last focus point click, something like that. Vision, set vision, add vision, and we say set vision is going to be page X and page Y. And then here we're going to render it if it exists. So we're gonna say if vision exists, we render a circle with CX of vision 0, circle, and CY is vision 1. And then we're going to, so vision 0, vision 1, and let's do a radius of 5. And let's see if that shows up correctly. I'm going to restart the walk just for a little bit. Okay, so see how this isn't working correctly? It's getting the positions way off, which is annoying. And D3 solves that for us, doesn't it? But no, let's try doing it without D3. So without D3, we're going to need the bounding box of the ref, of the SVG. So we're gonna say const SVG ref equals use ref. And we're gonna have to import the ref, use ref, SVG ref, come on SVG. And we say ref equals SVG ref. And we're gonna get const bb equals svg ref dot current dot get bounding client rect. Okay, and let's console log the bb just so I can see what we actually get. And then we're gonna use that to calculate the actual coordinates within the SVG based on where you clicked. So dom rect xy width top right. I wonder what's the difference between x and y, xy and top right, bottom left. Very confusing. So what we are going to need is top and left. So for x, we say we have left minus page x, and here we're gonna have top minus page y. And I think that'll set it up correctly. Let's see. No. God damn it. Is it client X and client Y? This is stuff that I used to know a lot better, and I keep forgetting it. Console log event and SVG ref current get bounding client rect. So we're gonna console log those two, and I want to console log what we're calculating as well. Console log this. Okay. Now let's see. I'm doing it in the wrong direction. I always get this part wrong. So we take client X and we minus left and client Y minus top. And I think that's gonna work correctly. There we go. Okay, so we got that part. We can now place a vision on the board so that we have somewhere that we want to go. right? Cool. Now, the next step is making our random walk biased so that it tries to go towards that direction. We should also render a, let's do that. So we're gonna render a vision component that's gonna get x equals vision 0 and y equals vision 1. Interesting. Nobody is interested in this stream. Oh well. So we make the vision component. Where are we? Okay. Const vision equals component that gets an x and a y, and it's going to return the circle that's just x and y, but it's also going to put all of this in a grouping element, and that grouping element will contain a text. And let's actually use this. Transform is going to translate the whole thing to x and y, and then here cx is going to be at 0, cy is going to be at 0, so that still works. And we're gonna add a text that says vision, and let's see where. Cool. So now this text needs to be repositioned a little bit. So we're gonna say x equals -5. No, that's y. Y equals -5. Or actually, we can just make the anchor point in the middle. Let me look up how that works. SVG text anchor point, because I always forget the syntax. Text anchor middle. So if we say text anchor equals middle, that should work. Cool. So text anchor is middle, and then we say y is -10, and we have that. Okay. So the vision is going to be the focus point for our random walk. Now what we need next is for that random walk to actually be biased towards the vision. How the hell do we do that? So if we make, so here's where we choose the horizontal direction. Now how do you make a biased random? So we already have this that tries to make it avoid edges and loops circle back into itself, which is useful. Now here where we say math random more than, if it's more than, this gives us even odds. This is even odds to move in a negative direction. So either to go up or to go down or to go left or to go right. Now what we need to do is make these change these odds so that if you are below the vision, you are slightly more biased to go up. If you are left of the vision, you are slightly more biased to go right. That should work. Okay. Move in negative direction randomly. And we say here, bias towards the vision if it exists. So we're gonna say let up bias is 0.5. Bias towards moving up. Bias towards moving down. Let down bias equals 0.5. Bias towards the vision if it exists. So if the vision exists, then we're going to say if you are below the vision, if below vision, Then we say up bias becomes 0. Let's say 0.2. Yeah. If below vision, so we're going to calculate that separately. If actually no, let's see if we can just calculate that. It would be nice. Can we just do it as a distance? Yeah, we can do it as a distance. So we're gonna say if distance of our last step, where else am I using last step? Oh, I know where I'm using it, where I'm calculating the distance. So distance last step dot end. Okay, so if distance between last step dot end, that's where you're currently positioned, and vision is, oh yeah, no, we can't do that. So we're just gonna make it simpler. If last step dot end of 1 minus vision of 1, if that is, so if the distance between you and, if the vertical distance between you and the vision is negative, so this minus that. So if it's positive, you want to be biased towards going up. If it's negative, you want to be biased towards going down. More biased to go down, so it's going to be 0.8, else it's going to be up bias is going to be 0.2. More biased to go up. And then we're going to do the same thing for the other bias. More bias to go left. So 2. Yeah, I think that's gonna be correct. So up bias, left bias towards moving left. So we say left bias and left bias. Go left, go left. Are you to the right of vision? Are you below the vision? Okay. So we're gonna see if this works. Oh wait, no, we actually have to use it. So for the horizontal direction, we say left bias. So if a random number is higher than 0.2, you're biased to go left. If it's higher than 0.8, that means you're more likely to keep going right. Same with vertical direction. If the up bias is a small number, you're more likely to be going down. If it's a large number, you're more likely to go up. Up bias. Okay, now let's see. So we have that. And when we set the vision, that did not seem to change anything. Why is that? What am I getting wrong? Add step, set random walk. Oh, I am getting bitten by stale closures. Let's see. We're gonna console log here, and you'll see that the vision never shows up. So console log vision, and you'll see it's not gonna be there. See, when I click, the vision never changes. It always goes in the same direction. So what we're gonna do instead, so what we need to do is to restart the interval. So I'm gonna go down here, let's say vision. Restart walk. Come on, come on. Cool. We got it exactly opposite. We are crap. No. So the console logs have destroyed code sandbox, and I need to kill this tab because it's dead. So we're going in exactly the wrong direction when there's a vision. So we're gonna fix that. Come on. Okay. Computer's starting to struggle. Kill the console log. Where are you? Die, console log, die. Okay. So if I restart the walk, see, you start walking in the exact opposite direction because I got these things wrong. Haha. So we're gonna fix that here. And we're gonna fix it here. Now, when I restart this, you see we go to the vision and we stay there. And if we make a new vision, we start going towards that. So this is working. Yes. Okay. Now the next thing I need is to make the vision a little less strong because this is just way too strong. More bias to go. Oh, so wait a minute. Up bias. Yeah, no, this is fine. We just were calculating the delta between your vision and your current position incorrectly. So I'm going to make this a little less strong. And let's see. Load the page. So we're walking randomly, we add a vision and we move towards it very quickly. Yeah. Sweet. Okay. I think this is a marvelous success. We got it working, guys. I know nobody was there. Well, numbers said there were some of you there. So on that great success, I'm going to finish for today. And there's going to be an article tomorrow where I will try to include this as an interactive widget on my blog. That was the whole reason why I went with making my blog in MDX, and now I get to finally use that. So thanks everyone for watching. I will see you again next week. Bye.